Today, let's start with the module 3, that is bandwidth utilization. To utilize the bandwidth, mainly we have two techniques. One is multiplexing and another one is spread spectrum. First, let us see why we require multiplexing and spread spectrum. Whenever bandwidth required by sender and receiver devices is less compared to bandwidth required by transmission medium, we require multiplexing technique. And we require the spread spectrum to increase the bandwidth of the transmission medium or link. I think you understood. For multiplexing is required whenever bandwidth required by two end devices, that is sender and receiver, is less than the bandwidth of the link. Spread spectrum is required to increase the bandwidth of transmission medium. Now let us see about the multiplexing. We can define the multiplexing as it is a technique that combines various input streams into a single stream and transmit it over one link. Here we have the diagram regarding the multiplexing. This is a multiplexing at the center side and we have the demultiplexing at the receiver side. At the center side, we can see n input lines. These n input lines carries input streams. Those are input to the device called multiplexer. Multiplexer will combine all the input stream and make it as a single input data, and then it will pass it through the link or transmission medium. Then from that, at the receiver end or before receiver receiving the input, that has been input to the demultiplexer, where demultiplexer decompose the combined stream of data into a various stream and transmit them over the respective output lines. And in the same diagram, here you can see they have written it as one link n channel. The meaning of this is there will be a single link. That single link has been divided into n number of channel. The actual meaning of link, again I have written the same thing in the note. The actual meaning of link is nothing but the actual physical path through which the transmission takes place. And the meaning of the channel is nothing but the portion of the link which is used to carry the data stream. That is nothing but the channel. In the concept of multiplexing, we are going to divide a single link into various number of channels. Now, here we have the various categories of multiplexing technique. I think you can see this. These are the three categories of multiplexing technique. Again, based on the type of data, that is analog data or the digital data, we have the various techniques. FDM, it is nothing but frequency division multiplexing. WDM is nothing but wavelength division multiplexing. TDM is nothing but time division multiplexing. Now, we'll see about the FDM, frequency division multiplexing. This is the diagram for frequency division multiplexing. What we are doing, mux is used at the sender side, demux is used at the receiver side. Both are connected through the transmission medium or the link. And here the link has been divided into three channels. And for all the three channels, different frequencies have been assigned. So frequency division multiplexing is nothing but where we are dividing the entire frequency into the various channel by assigning the frequency range. And at the input side, multiplication takes place. At the receiver side, at the receiver side, demultiplication takes place. Here we have the diagram for multiplication process. here we can see the baseband analog signals as the input, and input streams will have the similar frequency range, and those are input to the modulators. Modulator will generate the signal with the different carrier frequencies. Then those are input to the multiplexer, where it combines all the different carrier frequencies. Combined signal is transmitted over the transmission medium. Here we have the demultiplexing process. In demultiplexing process, we are going to use a filters, where a combined signal is input to the various filters. Filters, what they will do? They will filter, or they will decompose the combined signal into different components. Those are again input to the demodulator, where demodulator separate the signal with their carrier frequency. Hence we can re-obtain the original analog signals. You can just compare it and see the input of multiplexing and see the output of demultiplexing. Both are same. So multiplexing is nothing but combining, demultiplexing is nothing but separation. Now we'll see where we are going to use the technique called FDM. The FDM is a technique that can be used in the radios and televisions. Here we have example. In the example what they have given, voice channel occupies a bandwidth of 4 kilohertz. So input is of the type voice channel, its bandwidth is 4 kilohertz. We need to combine 3 voice channel into a link. The meaning is a single link is divided into 3 channels with the bandwidth of 12 kilohertz. So the bandwidth of the link is 12 kilohertz, and it should starts from 20 kilohertz and it should end with the 30 kilohertz. Here the meaning is range of frequency is 4 kilohertz, and your first frequency starts with the 20 kilohertz, last frequency or the frequency ends with the value of 32 kilohertz, and you need to divide the entire bandwidth link into 3 channels. Entire link bandwidth is 12 kilohertz. Then you need to draw the diagram. Since they have given it as a voice channel, they have drawn the input devices as the telephones, and as a input streams will have the similar frequency range. So the similar frequency range is 0 to 4 kilohertz, as they have given that channel occupies the bandwidth of 4 kilohertz. It is input to the modulator. Modulator will generate a different carrier frequency. So it will start with the 20 kilohertz. 22 plus 4 is 24. Next one is 24 plus 4 is 28. Next one is 28 plus 4 is 32. So it starts with the 20 kilohertz and ends with the 32 kilohertz. All three are combined, and combined or composite signal has been generated. Now it is passed through the transmission medium. Now the combined signal is input to the demultiplexer, where in the demultiplexer we are going to use the filters. Filters will separate this combined signal into separate components. Then they are input to the demultiplexer, where it will separate the carrier frequency from the original signal. Then the original signal has been generated. That original signal is passed through the N output lines. Now here we have the second problem. In the second problem, they have mentioned there are 5 channels. Each channel has a bandwidth of 100 kilohertz, and in between each channel you have the guard bands. So first try to draw the number of channels. Take one link. Over that link you have 5 channels. When you have the 5 channels, gap between the channels is nothing but the guard band. So for 5 channels you require 4 guard bands. For 6 channels you require 5 guard bands. Always the number of guard bands required will be one less than the channels required. Now each of the channel is having the bandwidth of 100 kilohertz, where the bandwidth or the frequency of the guard band is 10 kilohertz. You need to calculate the entire bandwidth of the link. So entire bandwidth of the link can be calculated as just by adding all these 100 plus 100, 200, 300, 400, 500, 500 kilohertz is the total bandwidth of all the 5 channels, plus 10 hertz is the first guard band, plus 10 is a 20, plus 10 is a 30, plus 10 is the 40. So 500 plus 40 is nothing but 540, which we can represent as 5 into 100 plus 4 is the number of guard bands into 10 is the frequency range of guard band. Then we have the wavelength division multiplexing. Your wavelength division multiplexing works in the similar manner of frequency division multiplexing. Just the difference is, in frequency division multiplexing, electrical signals are passed through the transmission medium, whereas in wavelength division multiplexing, it allows the transmission of optical signals. To transmit the optical signals, you require the transmission medium of the type fiber optical cable. And FDM, that is frequency division multiplexing, is used whenever bandwidth required by the sender and receiver device is less than the bandwidth of the link. And WDM is used to make use of high data rate capability of optical cable. And to multiplex and to demultiplex the optical signals, we are going to use the prism. These lambda 1, lambda 2, lambda 3 are nothing but the wavelength of the different optical signals. They are incident over the prism. In the prism, when they are incident, it generates the angle of incidence. So when it moves from prism is a one medium to another medium, then there will be a calculation of angle of refraction. Then it passes over the optical fiber. From optical fiber, it is input to the demultiplexer, where the separation of signals with the different wavelengths takes place. And over the transmission medium, we can see it, the sum of wavelengths as lambda 1 plus lambda 2 plus lambda t, which means we can just tell that the capacity or the data rate capacity of the optical cable is higher than the other transmission medium. And application of WDM is nothing but the SONET type of network, synchronous optical network. This is the type of network where the transmission of optical signal takes place. I think everyone know about the laser. Laser technology will come under the type of WDM. And in the WDM, there is another type of WDM called DWDM, where D stands for dense. The meaning is, in DWDM, it consists of large number of channels when compared to only WDM, where all those channels are placed close to each other. Okay, we'll carry rest of the topics in next class.